Hi everyone, welcome to this Let's Make video. I've been doing some of these tutorials through text and I figured it might be a good idea to start doing them through video. It's going to be kind of laid back. And the first one I'm going to do is actually one I've already created. This is creating a character that slows down when going up a steep hill and speeding up when he goes down. I originally fixed it using tracing, did line traces, but realize now that that's not really strictly needed. We can actually just compare the last location to the current location and get the same information really quickly. So let's do it. First, let's go ahead, let's take a look at our default character. This is the third-person template character, so nothing in it but the original code Epic gives you. If we jump over to our content browser, we can see the third-person character here. You can use a different character as long as you have a character movement component in there. We also need one other asset though, which is a float curve. We're going to use that to drive our speed based on the angle. So we're going to get our angle, 45 degrees let's say, and we're going to input that into our float curve. The float curve is going to output a speed for us. So based on that 45 degrees, it'll say a 500 speed. Using a curve just makes it a little bit easier to control. So if we right click, and we go down to miscellaneous. We can go to float curve here, or if you're on older ones, I think you might have to go to curve, and then select float curve. I'm going to call it FC for float curve, and we'll say speed angle, and save it. If we open it up real quick, we can check out the line graph. At the top, you can see this is our time going from left to right, and up and down our y-axis is just our value of what it will output. For us, we aren't going to be using this as time. This is actually going to be our angle. We'll feed it in an angle, and it'll output anywhere on this graph, whatever we give it. So if you hold down Shift and click, we're going to add in 4 points just kind of along here. We need to do it from a negative angle to a positive, and then give it values for the speed that we want the character to have. I'm going to go to the top left here, we can type in exact amounts. I'll go negative 45, and negative for us is actually downhill, so we want our speed to be pretty quick. Default speed I think is 600 for the third-person characters, so let's bump it up to like 900. The next dot we're going to put down to our kind of threshold of normal speed. This is going to be where the character kind of levels out on pretty much even terrain. I like to give them like a slight threshold, so if there's like a tiny little bump, we don't really need to do speed changes then. So let's say negative 10 degrees, and our value will be the default 600. You'll notice that our dots go way off, so we can just hit these two to fit, or you can hit the F key, and it'll fit around everything. Alright, so the next one, this is again our threshold. We kind of want this to be even. This will just be the opposite, so we did negative 10 here. So positive 10 degrees, we want anywhere in between there. That's going to be 600 for us. That's just our default speed. And lastly, going uphill, we have like a positive 45 degrees. We can put it down to like 100 speed, so it'll be moving really, really slow. The last thing I want to do is change these from being these linear kind of curves to actually having a curve. We can do that by right-clicking and going to Auto. You can also hit the number 1 key. But this one will have to flatten out, so you can right-click and go down to Flatten. And this will just give us a nice kind of curve for it. So that looks good. Let's jump back into the third-person character. Alright, this is just the default character. Nothing in here but the basic code Epic gives you. This is keyboard and mouse input stuff. We're going to be using our tick function to drive this speed change, just because it's a speed change and we kind of want it to be happening all the time. You don't have to do this, you could put it in a timer if you wanted, but for us it's just pretty easy to put in a tick, especially since it is something we want to update a lot, and it is pretty lightweight. It's not going to be doing too much computing. So we can right click, we can type in tick, and here's our event tick, drop it in. I like to comment everything, so I hit C, throw a comment on it. It's just easier to group. I'll just put update for now, but normally you put a better description in there. Delta seconds, we need this for our change in time. So our movement is going to update that speed, but it's not going to be instantaneous. We're going to do it over time, so it kind of eases into whatever our new speed is, which means we need our delta seconds. This is just the time between our last tick and our current tick. It helps to smooth everything out. So we drag it off and go to promote to detail, or promote to variable. We can drop one in, and we'll call this delta time. Now that we have this as a variable, you can kind of see it shows up here. My detail section's over on this side. It might be underneath this for you guys. I just like having them kind of separate to have more room for them. Now we need to create some functions that will change our character speed, and we're going to do it through 4 different functions. The first one we're going to create is going to be a container. This is just a way for us to call one function and have everything be called after it. So let's go ahead, hit new function, and we're going to call this one update character speed. This is going to update our speed based on the slope we're currently on. I'll throw a comment around it too, real quick. And we want to create 3 more functions. And the first one we're going to be making is a check if we should even update our speed at all. So we'll do a should update function. We'll do a get speed angle function. So that'll calculate our speed based on the angle. And then we'll do an update movement speed function. So let's add all 3 in. Go 1, 2, 3. And I'll jump back into the update character and drag these out. Alright, so let's rename them. The first one we can say is should update speed. And we want to connect this up and add an output. Now our output is just going to show up right here. You can just call this should update. And we need to branch based on that. We can hold down B and click. You can add a branch in, which is pretty useful. Or if you drag it out and type in branch, it'll auto-connect everything, which is nice too. And we only want to move on if it's true. So if we shouldn't update, we're done. We can move on. We don't want to do the rest of this stuff. This next function, let's rename it to get, you can do get speed angle, or let's say angle speed. And we need another output. This one, instead of a boolean though, we're going to change to a float, because this is going to be our new speed. We can call this desired speed. It's going to be output based on that curve we made earlier. It'll get everything, get the curve info, output this to our next function. The next function, let's call update movement speed. You guys can come up with better names. We need a float input to take this desired speed. We can name it the same thing, desired speed, and we'll bring it in from here. And that should be it. So we got all of our functions set up. Now we have to go in and create how each one will work. And let's start with the should update. And first we kind of have to realize what we want our should update to work on. When should we or should we not update our speed? And for us, we can do a couple things. For now, let's just keep it based on, let's say, make sure we're not falling. We want to make sure that our character is on the ground. If he's jumping or anything, we don't need to change his speed based on this. And we also need to have velocity. If the player isn't moving, we don't really necessarily need to update this either. It's another way to say, you know, don't bother just because we don't need to. So we need 2 of them, 2 booleans. So we go to an AND. We could drop this in. And this just states, okay, if we do have velocity, we'll come in here, and also if we are not falling, we'll come in here. And only if both are true, will output true. If one is false, it'll output false, even if the other one is true. So how do we get the falling in velocity? We can do it through our character movement. So this is our component that we have built in. We can go ahead and get falling, or I'm sorry, is falling. Is falling. And we want to say not, because right now this will return true if we currently are jumping or falling. We want to make sure we're on the ground. So if we go into a not boolean, this will change it from whatever it comes in as and give us the opposite. Next one, in the character movement, we can go ahead and say get velocity. Right here at the bottom, velocity. But this is a vector, and we want to just get if he's moving at all. So a good way to do that is just to get the length of that vector. And we can do the vector length, which is, we'll get the actual speed, or we can do length squared, which leaves out that square root, which is faster. And the reason why we can do it here is because we're not really looking for a value. We just need to make sure it's not 0. And if it's 0, it'll come through 0 here no matter what. So greater than 0. Which would mean that we have at least some velocity. Alright, this should be good. We're all set. We can close out, jump back out here. So this will only go through if we are on the ground and moving. Next thing we need to do is get our speed based on the angle. So I'm going to comment again. So get angle speed. In here we need to get our floor angle, and we need to get value from our curve. And then we'll output that value here. So previously I did line tracing as the way to get the floor kind of angle, but it's kind of overkill here. What I didn't realize at the time is that an easier way just to do it is just to check location, most likely because I was just overthinking it. So what we can do is we can get our previous location and our current location, and we can use that to figure out the angle we have here. So if we have our character here, if this is the last frame that we checked, and this is our current frame here, the current frame, we can go ahead and take this location and use it to get a look at node. They have a special node for it, which is nice. But we can get the angle based on these two positions, which makes it pretty easy and pretty nice. The one thing to note is that this doesn't quite work for elevators or anything like that. If your player is going to be moving up and down without actually being a part of his movement, it'll mess with this. In that case, you can always go back to this should update speed, and you can do stuff like get base actor, and check to see if he is on an elevator or something like that, which is nice. They have that built into the character. So we're not going to worry about it right now. Let's just get our angle based on the two locations. So first thing we need to do is get our current location. We can right click and say get actor location, and this will output our current vector. And like I said before, we have a nice function called get look or find look at rotation. Yeah. And this takes into vectors, and it gives us a rotation, so we don't have to even worry about that stuff, which is nice. But we want our target to be our actor location, so I just alt-clicked and deleted that connection, put it into this one. And our start is actually going to be our previous location. We need a variable for that. So if we drag out and say promote to variable, we can add in a new one. We are going to rename it to previous location. And again, we need to set this after we do this kind of look at rotation stuff. So let's get our current pitch. We actually don't need any of the other rotation stuff. So if we break this rotator, we have the roll, pitch, and yaw. Again, we're only interested in the pitch, which is kind of that up and down kind of rotation. So once we have this, we need to feed it into our curve. We need to add in a variable to hold that curve so we can kind of reference it. Click variable. We can go for float curve. Go ahead and reference. And let's call this one our speed curve. And compile. When we compile, we have a default value we can put in here. We just need to find the one that we created. So if we go out here, here's our speed angle. And we can look through it through the drop down, or you can even drag it on there, which is nice. But here's our speed angle now. If we compile, we're all set. And all we have to do is drag it out, get it, and we need to feed in the pitch to get out a value. So if we drag this off, we can say get value, get float value, and we'll see this in time. And again, our time is what was going from that left to right. We're just using it as an angle. It'll output our desired speed based on that angle. Something to note though is we can't just connect this here. The reason is because before we leave this spot, we're going to be updating our previous location. If we hold Alt and drag this out, we can get a set node. So if we would update this before we hit this point, this will not get the value until we get here. And at that point, our previous location is going to be set to our current. And that means everything will be right on top of each other, and this angle will change. So we can't do that. What we actually want to do is set our desired speed before we get to this previous location. We can do that through a temporary or local variable. You can add one down here if you want, or you can drag off and say promote to local, which is nice that they added that in. So new local, we're going to call this one speed, just for our local purposes. Local variables are going to only exist in this function. So outside this function, this won't be here. And every time we come through, it's going to be reset. It doesn't save it. So if I drag out speed, I can drop this in here. All that's going to happen is we're going to set this so that we can save it for later. And we're going to set our previous location. We just need to copy our get actor location, paste it in here, drop it in there. And then we're all set. So we get our previous and our current, find the rotation for it, get the value based on our curve, and then output that after we set our previous location for the next frame. So the next frame, our previous location is our current. Our current will be updated based on wherever we're moving. All right, last thing, update movement speed. And this one's pretty simple. Go ahead and we'll drop in a comment. All we're going to do is interp to the desired speed. So the interpolation node just tries to get there over time. And we have to do that through our character movement again. So if we hold control, drag this out, we're going to get max walk speed. The walk speed is just our current ground speed. It's the speed our character is going to be able to move across the ground, as opposed to flying or swimming or anything like that. We need to feed this into our interp, float interp 2. What this does is it just tries to get from our current value to the target value over time. And we just feed it in the delta time and a speed to kind of control how fast it does that. So let's get our delta time. And we can hook up our target to this desired speed. I'm going to double click Add in a little reroute node. And we can add in a interp speed that we kind of want here, the rate that it's going to go, but I like to put everything in variables just so it's a lot easier to keep track of. So we can promote to variable. We'll give us a new one. We can rename this to, say, speed rate. Say desired speed rate. And we need to change this once you compile from 0 to something else. So we could say like 4 for now. Once we do this, we need to feed it back into our character movement speed. Because we're getting it, but this doesn't actually set it back to whatever we have. We have to set it. So let's copy paste and set max walk speed. So we get it, update it, and then we need to set it. And once we have this done, we should be good to go. If we go over everything once more, first we check to see if we should update our speed. Again, you can check if you're on an elevator or something like that. We get our angle speed based on that curve and whatever angle we're currently on. And then we update our current max walk speed over time. The one last thing we have to do is we have to jump back out to our event graph and we have to add in our update character speed, which is that container for everything. So we have everything being run every frame. Compile and save. Let's see if it works. Yeah. So now you'll see that character slows down, and once he gets back up top, he speeds up. Going downhill speeds up more. So one thing you'll notice is that this change is pretty quick. It's because we're on that constant rate of 4. And the last thing I want to kind of show you guys is to change it based on our direction instead of just on that constant value. So we can do that instead of using this constant rate. We can just delete that completely, and instead we're going to use a map node. I'm going to use a clamped version just to make sure everything stays within the bounds of whatever I set. So the clamp or the map is just going to take a value in, and it's going to output a value based on whatever numbers we put in here. So we have our desired speed change. We can use that to drive this. Whenever we get this desired speed, we can tell it based on whether we're trying to go faster or slower, if our rate should be faster or slower. So if it comes in and we're getting a speed that is at our low end, like 100, which is the slowest we can go based on that curve, we can output a value that is much lower. Let's say 1. So if we're going slowly, if we're trying to make our character slow down while he goes up a hill, we can say, okay, that change is going to take longer, just so that the momentum looks like it's being used instead of instantly changing. On the other end, the in for 100, if we go for the high end, which is 900 for us, we can say that change actually is pretty quick. So if we are leveling out or going downhill, that change in speed can happen like almost instantaneously, just because we're it's really easy for someone to build up speed going downhill. So we can put in 6 there. So if we save, compile, let's check it out. We can see this pretty easy on the So you can kind of see that change happens really fast when we're leveling out, but when we're going uphill, it slows down over time. So you kind of feel like your character is using that momentum, as opposed to just kind of instantaneously changing, which in this version feels a lot nicer, I think. That about wraps it up for this Let's Make video. Feel free to comment or ask any questions. See you next time.